Let's talk about how Apache Iceberg is the future of data lakes. Companies like Netflix, Apple, and Adobe manage petabytes of data using Apache Iceberg. Apache Iceberg is not just a table format; it's a modern data lakehouse, providing AC transition, schema evolution, versioning, and time travel. I am Alvaro Justus, solutions architect at BIX Tech, and I am excited to show you how Apache Iceberg is essential for the future of data lakes. Okay, so we'll go step by step covering what is Apache Iceberg and how it's different from Hive, Delta, and Huit. How Apache enable AC transitions in data lakes, setting up infrastructure, starting Docker containers, configuring MinIO as storage for Iceberg, run upstream to data carry Iceberg tables, run Spark job to ingest and manage Iceberg data, and versioning time travel with NASI, and create a demonstration using Iceberg for creating, modifying, and restoring Iceberg data. And the last topic, we're going to cover how to optimization for scalability and performance. Now that we have your plan, let's dive in. Apache Iceberg is optimized table format and a unified storage layer for data lakes, providing easy transition, version time travel, schema evolution, and optimization. It enables efficient carry across multiple processes engines like Spark, Flink, Trino, Dremel, and Iceberg also support multiple storages like S3, Blob Storage, Google Cloud Storage, MinIO, ensuring high performance. When it comes to data lakes, Apache Iceberg is a game changer. It offers flexible schema, updates, automatic partitioning without the tables rewrite, time travel to access past dated versions, and better data management. Unlike Huge, which is built for incremental updates, and Delta Table, which is closely tied to Databricks, Iceberg is more open, adaptable, and scales effortlessly across engines like Spark, Flink, and Trino. Okay, and how Iceberg enables AC transition in data lakes? Apache Iceberg enable AC transitions in data lakes through immutable snapshots, read or write isolations, measure on read, safe rollback, and efficient metadata management, ensuring reliable operations without reprocessing. Okay, so let's put your hands on. Okay, here we have our Docker Compose. That is your infrastructure. Here we have a Dremel, MinIO, and Sparky with Jupyter Notebook and NASI. So we have a volume dedicated to without services for each services, and all these components are in the same network. Okay, so let's start the containers. First, let's start the MinIO service. Okay, I will open a new terminal here. Okay, now we have our first service online. Let's go in your browser and config the buckets. So here, okay, we have the credentials on my env file here. This will be put in the future. So now we need these credentials here. MinIO admin. Okay. Okay, now we're gonna create a new bucket. Okay, warehouse, create a bucket, and gonna create a second bucket, call it data lake. is this. Now gonna start another services. Let's put up the Spark notebook in the second terminal. Docker compose up Spark notebook. Okay, now we're gonna create a new credential here in Minayo. Create a new access key and put this in .env file. So we copy this and put here and cut this and put here. Okay, gonna save, create. Now, we don't need to download this, so it doesn't matter. Okay, now we're gonna start the second service in another terminal. Docker compose up Spark notebook. Okay, your browser. Okay, and now enter here and create a new notebook here. Okay, let's go back to the root table. Here we have permission. Okay, at this time we can start the third service. It's Dremio in another terminal. Docker compose Dremio. Okay, let's start another service while we wait the Dremio is going up. Nessie. Okay, now is going red and think all the services are up and okay. No problem here with Nancy, no problem with Dremio. This is okay now. Okay. Okay. Let's go create your Spark session and create a table in Spark here. So I have a configurations here to set up Spark import session and environments variables. So let's check if all the variables are okay. Remember, we put the variables in our .env file. Okay, our variables are okay. So now we're gonna configure our Spark session to read your Iceberg image and appoint the variables to the session. Okay. Let's start your Spark session. Okay, we need a little patience here. And I put symbol data here, so we have two files in the two formats. It's the same file, but in the different formats. So we have a sales data.csv and I have a Parquet file with the same content here. Okay, this is not a problem. It's just a warning. Oh, yes. Now, gonna read our files here. So the path of the files. Okay, so now we're gonna head and print schema and file contents. Okay, we're gonna read options like a CSV and a Parquet file. Okay, print schema. Perfect. Okay, now we're gonna create iceberg table. Uh, I put the principal columns here and using iceberg like SQL create uh, iceberg table. Okay. Okay, to make sure we have all the columns and don't have a header column, for example, we gonna select the columns that we're gonna use it. Okay, and now I'm gonna write the in format iceberg and create a table with Nessie in the save with Nessie dot sales data. Okay, okay, let's make sure we have a data ingestion with success. Oh, perfect. Okay, now let's open in your terminal Nessie. Nice. Okay, let's open Dremio. What is the part? Dremio. Here, I think. Okay. Nice. Let's go back here. And here we remember we created two buckets. We create a data lake and warehouse. We gonna at this moment we are using the warehouse buckets, but the data lake is empty. So I will install Minayo here. I forget to put this in the requirements file in the container. Perfect. Now I imported the Minayo configurations and I'm using another bucket to put this data lake. Nice. Need to be a string. Now we use the CSV. Remember, we just used the Parquet file here, and now we're gonna use CSV to put in another bucket. And I check in the Nessie before try. Okay, success now. Let me check this sales data, and now here it's empty. Data lake. I will check the buckets. Okay, data lake. Okay, let's try it again. Um, let me check again. Okay, I have a delay here to send because I'm trying to change the port address, but this is not a problem. Here is okay. Now gonna connect the Dremio with the Nessie. Okay, in the Dremio we need to make a register here. So I put the nice. Okay, in the Dremio we need to create a new data source. We have actually no one data source here, but in the true we're gonna create a two new data sources. But the first is the Nessie, and the Nessie we're gonna put this. Remember, we have Andres here, but in the Nessie is not V1, is V2. connection. Okay, and no need authentication. Storage here we appoint to our table iceberg. So the bucket our house. Okay, and then here we need to put our credentials again. Okay, and here we need to uncheck this and create a partner to connect with MinIO. So just repeat this. Okay. Endpoint. Nice. MinIO address. And hit compact. Check through. Okay. We don't need to do nothing here. Oh yes, we have our first connection. So I'm see before that we have two connections, but let's create another connection with we create another table from this data. So okay, now I will demonstrate the first iceberg connect is full schema evolution. So enter our data here. Okay, let's explore our data. I'm gonna run this first. Okay, here we have synthetic data for e-commerce that sells products from sports, and we have a category of the products, subcategories, product names, and territory that is sold and sales amount of this eating in this country and other data. So let's explore our data. Okay, we have three distinctive products categories and a lot of subcategories items. Okay, so what is the full schema evolution? So I'm gonna select all from Messi sales data. Need this. Okay, just run this again. Okay, imagine that we need to add a new column. So here we can alter table without need to rewrite the table. So it's very easy. Discount price. Type double. Okay. Oh, I forget this again. My fault. Sales date. Okay. New column are created. Let's check this. Nice. Here. Okay, so let's make an update to fill this new column now. We're gonna update it discount price with 50% of discount where we have mountain bikes as a category, and in the sales territory country is United States. Let's run this here. Okay, let's check this. We put a new column without need to rewrite. Okay, here we have an example here. United States and mountain bikes as a subcategory. Okay, let's explore the team travel propriety from the iceberg. So here we have a history of the alteration that we made in this table. So we have a two histories. So we have a when we change this data here, and we have a snapshot ID here. Okay, now we're gonna select it from this first snapshot. So select it from Nancy sales data to snapshot. Got this. Oh, is here is at node 2. Okay, so where is the new column? This is the magic of the time travel. So here we are carrying from a snapshot, not from a production table. So we're gonna roll back to a snapshot ID. So if I make a carry again, the new column is gonna appear here. It's okay. But when I make a carry from a snapshot, we never created this new column. So let's go roll back into the snapshot. So roll back table and see dot sales data. Now it's going to snapshot. Okay, let's go back here. Okay, let's check your rollback. Okay, okay, let's explore our data. So we have a e-commerce of Spark items here. Oh, another point. We can roll back at time too. So let me check here. Okay. Now we can make this to here table, but here we can put this timestamp, put exactly timestamp, and go back. Okay. I think I can back here because this is current version of the table. Oh yeah, this is the current snapshot. So, but we can do it too. Okay, we have set up Apache Iceberg and explored time travel. Now, let's look at the features that make carries more efficient, hidden partitioning and data compaction. That's in the part 2. See you there.